Good afternoon, spaceflight enthusiasts. In just over 24 hours from the time of this recording, both NASA and Japan will be dispatching missions to the moon, both hoping to set down on the lunar surface to accomplish technology demonstrations and scientific reconnaissance in advance of a future permanent human presence on the moon. Both Japan and NASA are focused on this objective with two primary goals in mind. Number one, to learn as much as possible about our natural satellite before we try to establish a permanent presence there. And number two, to establish an Earth-to-Moon transportation network and supply infrastructure, which will be absolutely vital if astronauts are going to be living on the lunar surface 365 days a year. And as with the previous two missions that NASA sent to the moon, and also the previous Ispace mission that was sent recently, both nations are trying to accomplish this goal on the cheap with private companies. And over the course of the coming days and weeks, we are going to find out whether or not that philosophy is truly effective, or if the notion of trying to do anything on the moon on the cheap is a terrible idea to begin with. All of this and more coming at you on The Angry Astronaut right now. Near the moon's eastern limb lies Mare Crisium, the Sea of Crises, which is a low basaltic plain surrounded by rugged mountains. Carved by a colossal impact almost 4 billion years ago, the 740-kilometer crater appears largely flat and featureless, but lingering whispers of a volcanic past are everywhere, from its ubiquitous darkness to craters flooded and semi-obliterated by ancient basaltic lavas, and a curious solitary landmark near its center, the 6-kilometer-wide Mons Latrier. And I'm probably mispronouncing some of this, and I apologize for that, but soon a robotic craft called the Blue Ghost will land here, carrying 10 scientific instruments and technology tests as part of NASA's Commercial Lunar Payload Services Program, or CLPS, which has definitely had its problems as of late, completely losing the Astrobotic Peregrine mission. And although the intuitive machine's Odysseus mission did manage to land on the lunar surface, its malfunctioning laser altimeter did not set it down softly. Instead, it landed on a greater than 12-degree slope, which exceeded its design limits. It broke at least one and probably more of its landing legs and came to rest on its side. Its payloads, for the most part, were able to function, but one could hardly call that a complete success. So this next mission, the Firefly Blue Ghost, is going to be a true test of this CLPS philosophy to see whether or not the moon can truly be explored on the cheap. And I have to say, the Blue Ghost does appear to be a pretty well-designed craft. Now, it's small, only 2 meters in height, but it's 3.5 meters in diameter, and I always prefer that for any craft landing on the moon, something to be squat and to have a wider base than it is high when you're setting down on an uneven surface. It has 3 square meters worth of space on its above deck, 4 square meters available on its mid deck, and 2 square meters of space available below decks. However, it can only carry 150 kilograms worth of mass to the surface. It's a fairly small craft compared to some of the CLPS missions, but it is still carrying 10 science instruments. And by the way, it's entitled Ghost Riders in the Sky, which I think is a great name for a spacecraft known as the Blue Ghost. Now, the Mare Crisium, as we spoke about before, bears witness to an active past, with long, sinuous ridges snaking across its eastern hinterlands, ghostly shadows of ancient craters, and the cape-like spit of Promontorium Agarum, which, again, sure, I'm mispronouncing some of this, abutting its southeastern rim, wider than the entire state of Arizona. This crater boasts a land area of 176,000 square kilometers, on par with the state of Oklahoma. Now, this is not the first time that human spacecraft have been to this region. As Neil Armstrong and Buzz Aldrin slept in the hours after their historic moonwalk, the Soviet Luna 15 robotic probe attempted to land in the Crisium, about 554 kilometers northeast of their landing site, but it hit a mountain during its descent and was destroyed. But undaunted, the Soviets tried again in 1974, and Luna 23 landed too fast and toppled over. Soviets didn't give up, though, and long after NASA stopped going to the moon, in 1976, Luna 24 not only went to the Crisium, but also managed to return 170 grams of lunar regolith back to Soviet scientists. These samples inconclusively hinted at the presence of 0.1% water by mass. And in 2018, NASA began hiring private firms to send small robotic landers and rovers to the moon, and one of these firms, as we said before, is Firefly Aerospace. We've heard a lot about these folks because they build rockets, they build spacecraft, they build a wide variety of spaceflight-related technologies, and yet this company was founded in 2017. Pretty quick development to go from where it started in 2017 to an orbital spaceflight company, and now a spaceflight company sending a lander to the moon. Tomorrow, on January 15th, 2025, this spacecraft will be lofted into orbit by SpaceX's Falcon 9 rocket and will be the first U.S. mission to this region. It can carry, as I said before, about 150 kilograms worth of payload to the moon, and it has 1 X-band and 3 S-band antennas furnishing communications and HD video. Body-mounted solar panels will give the spacecraft 300 watts worth of power for missions of up to 60 days. Now, once launched, the lander's voyage to the moon will take several weeks, giving Firefly time to validate Blue Ghost's health and collect data. After 25 days of circling the Earth, it will head for the moon and enter lunar orbit for an additional 16 days of testing. Then, on day 45, this will mark the mission's trickiest test, a nail-biting descent from its 100-kilometer orbit to the surface. About an hour before landing, Blue Ghost's 1,000-Newton main engine will ignite. The lander will then coast for 50 minutes as its terrain relative navigation system calculates altitude, rate of descent, and selects a suitable landing spot. 20 kilometers above the surface, it will pitch over, slowing from 6,100 kilometers per hour to only 145 kilometers per hour to position itself over the selected touchdown zone. The main engine will shut off at an altitude of 1,600 meters as Blue Ghost's 8 reaction control thrusters pulse periodically to fine-tune the descent, assuming, of course, that everything has gone properly. The descent has been practiced on Earth, by the way. Firefly performed dozens of drop tests on various surfaces such as sand, simulated lunar soil, and even concrete to prove Blue Ghost's shock-absorbing footpads can handle even difficult landing conditions. Alighting at 3.5 kilometers per hour, contact sensors in the footpads will signal touchdown, and after that, Blue Ghost Mission 1 can truly begin. For 14 days, Blue Ghost instruments will scour the environment and test technologies that may benefit future human explorers. Southwest Research Institute's magnetotelluric sounder, a magnetometer atop a 2.5-meter mast, will probe the lunar mantle to a depth of 1,100 kilometers. That's 2/3 of the way to the moon's core. And Texas Tech University's Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity, my God, what a name for an instrument, that will drill to a depth of 2.1 to 3.3 meters into the ground, measuring heat flow in the interior. Then the University of Maryland's Next Generation Lunar Retroreflector will help measure Earth-Moon distances with sub-millimeter precision, offering clues about the lunar interior and addressing questions about general relativity and even dark matter. The Lunar Environment Heliospheric X-ray Imager, provided by NASA, Boston University, and Johns Hopkins University, will observe interactions between Earth's magnetosphere and the solar wind. Then Aegis Aerospace Regolith Adherence Characterization will assess how abrasive lunar soil affects different materials, including solar cells, optics, and spacesuit coatings. And then Montana State University's radiation-tolerant computer will test hardened computing electronics on the moon's airless, radiation-drenched surface. Then, there's quite a few experiments here. NASA's stereo cameras for lunar plume surface studies will gather still and video images to reveal how Blue Ghost rocket exhaust displaces soil, rocks, and dust. That is extremely important because much larger spacecraft will be setting down on the lunar surface in the next few years, and we need to get an understanding of how much that's going to disturb the lunar regolith and what potential damage that might do. Data from its 6 tiny cameras will provide 3D surface views before and after touchdown, offering insights into how heavy landers and large habitats can be landed safely. And then Honeybee Robotics Lunar Planet Vac will use pressurized gas to pneumatically suck pebble-sized soil specimens into a collection chamber as a precursor for future sample return missions. And NASA's Electrodynamic Dust Shield will use electric fields to remove lunar dust from the lander, testing possible future uses in cleaning solar panels, radiators, camera lenses, and astronauts' spacesuits, boots, and visors from the damaging material. And there's one more. The U.S.-Italian Lunar GNSS receiver experiment aims to discern faint global navigation satellite system signals from lunar distances for the first time, potentially allowing Earth-based GPS-type sensors to be used on future moon missions. Whew! 10 experiments, all of which are pretty critical to our future ambitions on the moon. But as cool as all of that is, incredibly, this is not the only lunar lander that's heading out on this same Falcon 9 mission tomorrow. The Japanese have their own mission, the Ispace Hakuto Mission 2. Mission 1 was not a success. The lander crashed while attempting to land on the first attempt, so Ispace is going to be taking another shot at it. And thus far, they've at least completed their first milestone, which is to complete all development processes of the Resilience lunar lander before flight operations, to contract and prepare the launch vehicle, and complete integration of the lunar lander into the Falcon 9, obviously, and then to prove ability to flexibly manufacture and assemble landers in various geographic locations around the world, which they've also managed to do because they have a European subsidiary that built the rover. And of course, they have 6 payloads on board as well. Milestone 2 presumably comes tomorrow, a successful separation of the lunar lander from the Falcon 9, and to reaffirm that Ispace's lander design and structure is capable of withstanding the harsh conditions during launch on the second mission, which it did on the first mission, so I'm pretty confident that it's going to do a good job with all of that. Success 3 is to establish communications links between the lander and Mission Control Center, confirm a stable altitude, as well as to start stable generation of electrical power in orbit. Success 4 is to complete the first orbital control maneuver, setting the lander on course towards the moon. By the way, this is going to take months. This is a very low energy approach to the moon, utilizing the minimum amount of propellant in the process, and gravity flybys being a big part of this process. Again, given the fact that we have 2 lunar landers in the same Falcon 9 mission, there would be no way to accomplish this any other way. You wouldn't be able to do 2 direct missions to the moon, at least not with landers this size, on a single Falcon 9 mission. You would need a more expensive rocket like a Vulcan Centaur or a Falcon Heavy. Then Success 5 will be to complete a lunar flyby approximately 1 month after launch and to begin deep space flight operations. And then number 6, to complete all planned deep space orbital control maneuvers by utilizing gravity assist effects and to successfully target the first lunar orbit insertion maneuver and to reaffirm the deep space survivability of Ispace's lander design, which they did on the first mission, so they should be able to do it here on the second, as well as the viability of Ispace's lunar planning. Then Success 7, complete the first lunar orbit insertion maneuver and to confirm that the lander is in a lunar orbit and to reaffirm the ability of Ispace to deliver spacecraft and payloads into stable lunar orbits. Again, they did that on the previous mission. They should be able to do it on this one. Then Success 8, to complete all planned lunar orbital control maneuvers before the landing sequence and to start the landing sequence. Number 9, to complete the landing sequence, verifying key landing abilities for future missions. This is what the previous mission did not accomplish. And then finally, Success 10, establish a steady telecommunications and power supply on the lunar surface after landing. Whew! And guess what? They still have the payloads on board. This includes a water electrolyzer from Takasago Thermal Engineering Company with the objective of separating hydrogen and oxygen from water gathered on the lunar surface in the future, in other words, to produce rocket fuel, and also food production experiment from another company, and a deep space radiation probe developed by the Department of Space Science and Engineering National Center University in Taiwan. Then there's a commemorative alloy plate developed by Bandai Namco and modeled after the Charter of the Universal Century from the animation Mobile Suit Gundam UC. Definitely a Japanese kind of payload there. And then the Tenacious Micro Rover. This very important, developed by Ispace Europe. This rover will explore the landing site, collect lunar regolith, and relay data back to the lander. It will be equipped with a forward-mounted HD camera and a shovel. And then finally, a payload called Moon House, which is a model house by Swedish artist Michael Genberg that will be mounted on the rover. And Ispace in the future has much more ambitious payloads in mind. They have recently established an agreement with an asteroid mining company in London to carry some of their robots to the lunar surface to explore the possibility of mining on the moon utilizing a spider rover called the Space Cargo and Reconnaissance Explorer, or SCARE. And Ispace has some very lofty ambitions of establishing a permanent human presence on the moon, including a lunar base, but these are the beginning missions. These are the first reconnaissance missions being sent to the moon that have not experienced the greatest degree of success up to this point. The most successful mission was the Indian Chandrayaan mission. Other than that, there has been very limited success with these CLPS missions, or even from the Japanese as well. So this will be an acid test. Can these companies and can these space agencies learn from their previous mistakes and successfully set down on the lunar surface for the first time in over half a century? Thank you very much for watching. Please don't forget to like and subscribe. And also, I'd like to thank the 6 new Patreon members who have signed up so far this year. Thanks very much. I can't keep this channel going without your support. If you'd like to join these folks and take advantage of the exclusive content available in my Patreon exclusive library, which, by the way, will be adding a new title this month entitled The First Real International Space Station, about the Soviet Salyut 6. A lot of details I certainly didn't know about this historic space station and its accomplishments, featuring all original music and animation from the legendary Digital Voodoo. A very, very special video coming out for Patreon supporters. So if you'd like to take advantage of all that, the details are in the description. Thanks again for watching, and until next time, stay angry about space.